Hi guys, it's Bergen. We are going to be doing another combination homework, and this should be the last one. So your last combination homework is going to be 11.5 and 11.6. I am just going to quickly turn this around so we can talk about unit cubes and solid figures. All right, so you can build rectangular prisms using unit cubes. How many different rectangular prisms can you build with a given number of unit cubes? A unit cube is a cube that has a length, width, and height of 1 unit. A cube has blank square faces. All of its faces are congruent and it has blank edges. The lengths of all its edges are equal. So if you come over here and you look here, it's asking about the faces. Well, you can think of like a dice. Dice have, is a cube. So how many different faces does that have? A face is like this part. There are 6. So therefore that is 6. And then they want to know how many edges. Well, what you want to do on edges is they want you to go ahead and count each of these like little sides, but that's 1, here's 2, here's 3, here's 4. Then you have this 5, then you have 1 down here. Here is 6. This is 7 and 8. And then you have 9, 10, 11, and you're 12. So therefore there's actually 12 edges on this. Now it says they want you to build a rectangular prism with 2 unit cubes. So they want you to take 2 unit cubes and put them together. So hold on 1 second. Okay, so it says build a rectangular prism with 2 unit cubes. When the 2 cubes are pushed together, the faces and the edges are pushed together, making 1 face and 1 edge. So how many faces does this rectangular prism have, and how many edges does it have? So this is what they want you to look at. It's just like a box now if I fuse both of these together. So if you look, here is 1 face, here's 2, here's 3, here's 4, and then I am touching the ends. Here's 5, and then 6. So therefore there are still 6 faces. And then how many edges do you have? Well, up at the top you have 4. Because 1, 2, 3, 4. On the bottom of this, the very bottom of it, you have another 4. So far that is 8. Then you go along the sides. This is 9. Then this one is 10. Then over here is 11 going down, and that is 12. So you still have 12 edges as well. So what it wants you to do is build different rectangular prisms that you can with 8 unit cubes. Now I'm just going to tell you, when it comes to unit cubes, you will be talking about volume. So volume is length times width times height. So I want to talk about this real quick up at the top. I want you to write some things here. Say, for example, so area, we all talked about area already. Area is length times width. So in other words, like it could have been feet times feet. That was like you had a square. If you had a square or a rectangle, say this was 8 and a 4, you would have done 8 feet times 4 feet to figure out the area of this section. So since you are doing 8 times 4, 8 times 4 is 32, but then feet times feet is just like what we were talking about with exponents. 10 times 10 times 10 is 10 to the third power. Well, when you have feet times feet, it is actually feet to the second power, which is also known as square feet. When you only have 2 feet, it's always squared. So if it's a little 2 up here, that it is squared. But now that we're going to go into another dimension, we are now going to go into 3D mode. So because it is 3D, which is volume, everything is going to be cubic units. So I think Mr. Kopsak liked to say area is squarea. That is something that maybe you guys might have remembered. He liked to say area squarea, which means it's always squared, which always means to the second power, or so that is something that you could remember there. So it's like, even if it was meters, it would have been meters squared. Here, we're going to be talking about a third dimension now. We are now going to be talking not about the length and the width now, but now we're going to be talking about the height as well. So length times width times height. So, so in this case, say it was, now the height to this one was say 2. So now it would be 2 feet times 8 feet times, what was the other one? 4 feet, because length and the width still stay the same. Now we're just going to add a height to it. So in this case, it is now feet times feet times feet, which is really feet to the third power, which is also known as cubic. So I always say volume cubic, volume cubic, volume cubic, for you to remember that volume is always cubic units. That will never, ever change. And then area is squarea. Area is squarea because area is always squared to the second power, because there's only 2 dimensions, length and width, but this one we have 3 dimensions, length times width times height when it comes to volume. So in this case, you could have done 4 times 2, which is 8 times another 8 is 64 cubic feet, or feet to the third power. So you could have said cubic feet or feet to the third power. Either way, they're still saying the same thing. So when it comes to this, I always have, they said 8 cubes. If you remember Mr. Bryan teaching the factor rainbow, you can do the factor rainbow of 8, and this could help you find some of them. So 1 goes with 8. Also, can a 2 times something get to 8? Yes. 2 times 4 will get to 8. And does 3 times something get to 8? And that is a no. So in this case, because you have to have 3 dimensions, if I had 8 cubes here and I did it in this, I have a length that is 8 by how many wide? Well, it's only 1 wide. There's only 1 cube wide. So that is why it is 8 is the length. Width, it's only 1. So 8 times 1, but we have a third 1. So it's still to be 8, still to make this still say 8, it would be 1 high. And if you look, this is only 1 high as well. So that is one of the things that you could have said. Also, the other thing you could have said is you could have had a 4 by 2, because those two are connected, 4 times 2, and then to make it a third dimension and still equal 8, you could just say times 1. So in other words, what I could have done is I could have gone and taken these 2, 4, 6, oh, forgot these two. If I went and I took these and I kind of stacked them or moved them to the side here, this is showing that it is still, it's a rectangular prism that I just made. It is still a length of 4 now. There is 2 in the width, so 1 and 2. And then how high is it? Well, it's still only 1 high. So you could have said that as well. And the other thing that they wanted you to see is that you could have taken these 4 and stacked it on top. Oh, that's not gonna work. But anyway, you could have done that. You could have done a 2. They wanted you to also see that you could have broke this apart and did 2 times 2 and then times 2. So it would have been 2 is the length, 2 is the width, and then how many high that would have been. Another one. So you would have just have stacked this on top, and you could have done that as well. So they just want you to be able to, you don't have to build every single one that is possible. Just give me some examples. So therefore, you don't need to know how many different ones you could use with 8, but you need some options, in other words. All right, next that we are going to be talking about is we are going to explain why a rectangular prism composed of 2 unit cubes has 6 faces, and how do dimensions compare to a unit cube. So why does that 2 unit cubes, when we had that, still make 6 faces? So this is what I want you to say. One face of a unit cube completely covers the face of another of the other unit cube. And both are on the inside of the prism. The prism has 6 faces. And has 1 dimension. That is 2 units long, rather than 1 unit long. All right, so now it says how the number of edges of the rectangular prism compares to the number of edges for a unit cube. You can just say they are the same. which is 12 edges. Okay, now, the next thing I need you to write, don't worry about number 3, we're not gonna go over that one. There is something that I do need you to know. When there is gaps and in a prism, just count the cubes. When there is no gaps, it looks like a box. Which means you could do length times width times height. All right, so in this case, you can build other solid figures and compare the solid figures by counting the number of unit cubes. So here is a thing that they built using cubes. Now, keep in mind that when it goes and it goes over to the next corner, this is still the same one. It's just all sitting there. So don't count this twice, going this way and then another time going this way. This is all one piece. So if you wanted to count the cubes here, it is 1, 2, 3, 4, 5, and 6. So therefore this is made up of 6 unit cubes. Here, if you look here, how many unit cubes does this one have? This one has 1, 2, 3, 4, and 5 unit cubes. So the question is, so figure blank has more unit cubes than figure blank. So figure 1 has more unit cubes than figure 2 by just 1 more unit cube. All right, it says use 12 unit cubes to build a solid figure that is not a rectangular prism. Share your model with your partner and describe how your model is the same and how it is different from your partner's model. Well, you can't really do this, not even while you're in school now, because of all the whole pandemic thing. So you guys wouldn't be able to play with these anyway. So what we would have to do is we would have to see how many different types of 12 things that equal 12 can come up with dimensions for. So if you use that factor rainbow that Mr. Brian taught you on how to do 12, you always start with 1 and end with itself, which is 12. So 1 and 12 will go together. Does 2 times something equal 12? Well, yes, it does. 2 times 6 equals 12. Does 3 times something equal 12? And this is another thing. Yes, it does. 3 and 4 go together. So therefore, you could make, these are just some of the possibilities. You could have had 12 times 1, but remember you need 3 dimensions. So if you times it by 1 again, then it's still okay. This one is 6 by 2, but then you still want it to be 3 dimensions, so you can times it by 1. The other thing that you can say is a 4 by 3, but remember you need that 3rd dimension, so you've got to times it by 1. Also, you could play around with this. You could have separated out 4 as 2 times 2, and then you could have said times it by 3. That was another thing you could have said. So as long as you guys know that there are different possibilities that you could do to make that, that's all that they really want to know. All right, so now moving on to this. It says the rectangular prism is made up of how many unit cubes? Well, here it's just sitting there. Now I could, it does look like a box to me. So it's saying like I could do my length times width times height. Again, I always teach it as you pick a corner And you can do a forward L and a backward L, and those are your dimensions that you're going to be looking at. Or if you want to, you could have also done a capital T, put a line down, and then made a T with it as well. So as long as you did that, you would find all three dimensions. So you could have done, this would be a 1, this was 3 long, and this one was only 1 high. So you could have done 3 times 1 times 1, 3 times 1 times 1, which equals 3. Or you could have simply have just counted this one. This one was pretty easy. All you had to do is just count them. It would have been 3. So on this one, you could have done the exact same thing. Picked a corner and did a forward L and a backward L with it. And then you could have came up with your numbers here. Because this is a box, it looks like a box. There are no gaps inside. So how many high? Well, that is 3. How many going this way? That is 4. And how many going back? It's only 1. So therefore, you would have done length times width times height, which it doesn't even matter which number order you put them in, because remember when you're timesing, that is the commutative property, which allows you to switch the numbers because they're all multiplying, and it doesn't matter what you do first and what you do last. You can do it in whatever you would like, as long as these are the 3 numbers. So it doesn't matter what you picked. I could have done 4 times 3 times 1, and that would have been 4 times 3 is 12 times 1 is 12. So your answer would have been 12. Next, here you could have, these does not have any gaps as well. It looks like a box. So I could have chose to pick a corner, do a forward L and a backward L, and then use these numbers. So this one going this way is 2. This one going up, it is 2 units. And then going this way, it is 3. So therefore you would have done 3 by 2 by 2, or you could have said 2 times 3, it doesn't matter. So in this case, it is 6 times 2, which is 12 as well. And then this one, since this one does have gaps in it and it does not look like a box, this one is one that you have to count the cubes in. So this is 1, 2, 3, 4, 5, 6, 7. So this one would have been 7 unit cubes. All right, next it says, how are the rectangular prisms in exercises 2 and 3 related? So how are they related? And can you show a different rectangular prism with the same relationship? So how are they related? They both have 12 unit cubes. So they both have 12 unit cubes. And then they're saying, can you come up with a different one? So different one. This is, again, you could have picked their 12, which we did down here. So it had a 4 by 3 by 1. It also had the 3 by 2 by 2. So the ones that we could have also have said is a 6 by 2 by 1, or a 12 by 12, 12 by 1 by 1. Or we could have also picked 6 by 2 by 1 as well. All right, next, I want you to try this one, which is just try these two, see how many cubes this one is and this one is, and then correctly compare them using a less than, greater than, or equal to sign for both of these. So please pause that and try that on your own. All right, so on this one, since this one has a gap in it, you cannot just do length times width times height. So you actually had to go and count these. So if you counted these, it would have been 5 units. Here, this does have a gap as well. It does not look like a perfect box. So you would have had to count these as well. And if you did, it would have been 5 units as well. So therefore, these are equal to each other. Next, here, since this is a perfect box, you could have done length times width times height and just times them all, or you could have simply, in this case, just counted them. 1, 2, 3, 4. This is 4, and this is 1, 2, 3, 4, 5. And so since 5 is more, you would have gone and put the less than sign. 4 is less than 5. All right, next it says Melissa makes a solid figure by stacking one cube on top of another of 2 cubes on top of a row of 3 cubes. Then she arranges the cubes to form a rectangular prism. Describe the arrangement of the cubes of the rectangular prism. All right, so what it's saying is very confusing on how it just said that. It said she forms a solid figure by stacking 1 cube on top of 2 cubes. Okay, so 1 cube on top of 2 cubes. Okay, and then on top of a row of 3 cubes. So now we have 3 cubes. 1, 2, 3. So how many do we have? 1, 2, 3, 4, 5, 6. So they're saying, okay, this has 6 cubes. What are some of the other arrangements that you could have had with 6? Well, this is where that factor rainbow would come into play. 1 and 6 is one way you could have done that. So that would have been a 6 by 1 by 1. And then also you could have said 2 and 3 go together. So you could have also said a 3 by 2 by 1 as well. So that was just one or the other. All right, next. This one says the cube houses of Rotterdam and in the Netherlands, shown at the top right, were built in 1970s. Each cube is a house tilted on and resting on a resting. I think I meant to say resting. Okay, resting on a hexagon-shaped pylon, and it is meant to represent an abstract tree. The village of cube houses creates a forest. Looks like a forest. The Netherlands capsule tower, known as shown at the right, is of office and apartment buildings in Tokyo, Japan, made up of modules attached to 2 central cores. Each module is a rectangular prism connected to a concrete core by 4 huge bolts. The modules are office and living spaces that can be removed or replaced. So here it's saying, go deeper. There are 38 cube houses. Each house can hold 1,000 cubic unit cubes that are 1 meter by 1 meter by 1 meter. Describe the dimensions of a cube using unit cubes. Remember that the edges of the cube are on the same length. So remember, it told us the volume is length times width times height. So it told us that it could hold 1,000 of these meter cubes. So we know that we're going to be talking about meters. We just don't know how much. Now it said it was a cube. Now remember, with a cube, that if one side is something, then they're all that same thing. So what can we multiply by? The same number. It has to be the same exact number. So say that this is A meters, and A meters. They're all the same thing. What could be the same number here in A, and it's when you multiply it, they will be 1,000. So in here, it would have been 10 times 10 times 10. So therefore, if 10 times 10 is 100, times another 10 is 1,000. So then each dimension is 10 meters. All right, next, the capsule tower has 140 modules and is 14 stories high. If all the modules were divided evenly among the number of stories, how many modules would be on each floor? How many different rectangular prisms could be made from that number as well? All right, so what it said here is that there was 140 modules and it was 14 stories high. So it wants to know how much would be on just each floor. Well, in order to figure that out, I should divide 140 by 14, and that would come out to be 10 modules per floor. Now it's saying how many different rectangular prisms can you make from that number? So they're saying about 10. So just come up with some examples of what rectangular prisms I could make with 10 of these. So again, you could use your factor rainbow, 1 and 10, 2 and 5, that's good enough. That's just a couple of them. So you could have said a 10 by 1 by 1. You could have said a 5 by 2 by 1. And that is good enough. You could have said these kind of things. The next thing I want you to do is I want you to try this one on your own. I want you to match each one of these up with the correct amount of unit cubes. So please pause this and try this. All right, so if you did this, this is what you should have had as an answer. This one was a perfect box. So you could have just did a 3 by 2 by 2, and that would have been 12. 4 times 3 is 12, so that should have been connected to 12. This one, all you had to do, because there are gaps, you had to just simply count. If you counted them, that would have been 8. And then here, what they wanted you to see is, yes, there are 3 here, and then there are 3 here, but a lot of people forget about the row. In order for it to be elevated, that means a row of them had to be underneath this. So there was actually 3 back here as well. So 3 plus 3 on the bottom, that's 6, plus 3 more is 9. So that would have been 9 unit cubes. All right, so on the first part of your homework for 11.5 and 11.6, your first part of the homework would have been 2, 3, 4, 5, 6, 7, and 8. I am just going to quickly go over this one with you. A carton can hold 1,000 unit cubes that measure 1 inch by 1 inch by 1 inch. Describe the dimensions of the carton using unit cubes. Well, this was just like this one over here. So in this case, it is saying length times width times height equals volume. So it's already giving you your volume as 1,000. And remember, they're saying cubes, so they all have to be the same amount. So what number would have to be here to be the same so that this comes out to be 1,000? Well, each dimension is 10 inches to make it 1,000 inches cubed. All right, here it says draw and label examples of rectangular prisms that you could have built with 16 unit cubes. So you could use your factor rainbow again. I'm just going to give examples. I'm not going to draw them out. So there's 1 and 16 go together. Does 2 times something equal 16? Yes, it does. 2 and 8. And then you could have said 4 by times 4. So here are some examples. You could have said a 16 by 1 by 1. You could have said 8 times 2 times 1. You could have said a 4 by 4 by 1. You could have also split apart a 4 and said 2 times 2 times 4 is another one. So these are some of the things that you could have said. All right, on the back, I just want you to do just a couple here. I want you to do number 1. for homework. I'm going to do 2 with you. It just says about 18 unit cubes come up with different rectangular prisms. So we're just going to come up with some. So again, we need our factor rainbow. 1 and 18 go together. 2 times something, does that equal 18? Yes. 2 times 9 does. And then also 3 times 6 does. So some examples would have been, you could have chosen 18 by 1 by 1. You could have said a 9 by 2 by 1. You could have also said a 6 by 3 by 1. You could have also broke apart 6 by saying another 3 times 2 times 3. That's fine. You could have said that as well. There were several different things you could have said. All right, so that was just some examples. Also, I want you to do number 4 and number 5. So this is what you are going to do for 11.5 are those ones. And then 11.6, we're going to just do very quickly. 11.6 says that you can find the volume of a rectangular prism by counting unit cubes. Volume is the measure of the amount of space in a solid figure occupies and is measured in cubic units. So each unit cube has a volume of 1 cubic unit. So in this case, what they just did is they just split these apart, and it's saying this rectangular prism is made up of how many unit cubes? Well, it is made up of 8 unit cubes. So the volume is 8 cubic units. Now they want you to cut and fold things. We're not going to be able to do that. But I am going to give you some dimensions. We're going to say they wanted just to make our own little cube. So I'm going to say that we made one. The first layer of it will be a 5 by 5. And then, so this bottom part would have been a 5 by 5 here. Okay, so that is the bottom unit. And then it wanted to know how high is just the first layer. Well, just one layer would only be 1 high. So the height would have been 1. So now it's wanting to know what is the centimeter cube of that is used to fill the base. The base means the bottom shape. So the bottom shape is a 5 by 5 by 1 because it's only 1 high. So that is 5 times 5 times 1 equals 25. So that one is 25 cubic centimeters, or centimeters to the 3rd power. So now it says continue filling this rectangular prism layer by layer until you get to the very top. So how many centimeter cubes are in each layer? Well, in each layer, it is 25. How many layers of cubes to fill this rectangular prism? I'm just going to make up something. I'm going to say it took us 5 layers to get there. So how many layers to fill that rectangular prism? It was 5 layers high. So how many rectangular prisms needed to fill? Well, it was a 5 by 5 and 5 high. So therefore you had to do 25 times 5, or in other words, 5 by 5 by 5, which is still your 25 times 5. So 5 times 5 is 25, carry your 2. 5 times 2 is 10, plus 2 is 12. So that would be how many centimeter cubes would be needed? It would need 125 unit cubes. So therefore the volume is 125 cubic centimeters. All right, now we're just going to go into some of this here. I'm going to skip question 1. We're going to go down to question 2. If you had a rectangular prism that had a length of 3 units, a width of 4 units, and a height of 2 units, how many units would you need for each layer? And how many unit cubes would you need to fill the rectangular prism? So they want you to just look at the bottom layer first. So this is like your bottom layer. And then this is how high it is. Okay, so they're just looking at the bottom. They're saying that the bottom is the length is 3, the width is 4, and then the height is actually 2. So what would be in the bottom layer? Would just be one layer is 4 by 3, which equals 12 cubes per layer. And then how many layers are there? Well, now you would do 12 times 2 because that's how high. So times 2 would be 24 cubes to fill it. Next thing, it says to find the volume of 3-dimensional figures, you measure in 3 different directions. For a rectangular prism, you measure it in length, width, and height. Volume is measured using cubic units, such as cubic centimeters, cubic inches, or cubic feet. Which one will have a greater volume, 1 cubic centimeter or 1 cubic inch? So here's centimeter versus an inch. Which one would be bigger? Well, 1 cubic inch would be bigger because inches are larger than a centimeter. All right, so if you kept on going here, it says find the volume of a prism of each cube using 1 cubic centimeter, 1 cubic inch, and 1 cubic foot. All right, so what I'm going to do is I'm going to first say, all right, let's try each of these to be centimeters. So this is first going to be a centimeter, and a centimeter. All right, so you would do 3 times 6, which is 18 times 2. So in this case, here, I could do this. Length times width times height. It would have been a 3 by 6 by 2. Now remember, you don't have to go in this order. Remember, you could switch it around. So I like 6 times 2 is 12. So I'm going to bunch those together, then times 3, and that is giving me 36. So therefore, that would be 36 cubic centimeters. Now, what if these were inches now? Well, it is still the same numbers, but now the only thing is it's going to be inches. And then how about if they were in feet? Well, it would be still 36 cubic feet now. So would the prisms above be the same size if they were built with centimeter cubes, inch cubes, or foot cubes? And the answer would be no, because feet are larger than inches and centimeters. So it would be a larger prism if this was in 36 cubic feet. All right, next, in order to do this, you could do, you have to do the volume. Remember, volume is length times width times height. So you could pick a corner and do a forward L and a backward L. Well, in this case, this is the corner, but you got to go and search for that. This is actually saying 3. So you could do 4 by 4 by 3. 4 by 4 by 3. Again, you don't have to multiply in that exact order. You can skip around because these are all multiplication. So 12 times 4 is 48. So therefore this is 48, but then it is in cubic, and you guys see what it is talking about. It is talking about cubic centimeters. All right, here, in this case, again, pick a corner, which I'm gonna pick this one, and do a forward L and a backward L. So they did not give me this one, so I can just search for it. Remember, this is the same as this, so this is 4. So you could have said it is a 3 by 2 by 4. Well, 3 times 2 is 6, times 4 is 24 cubic, and then now what do you say is the units is inches? And on your homework, you have to make sure you are saying these correctly as well, or I have to mark them off as wrong. In this case, what would be the volume of this? So you would have to do, again, length times width times height. So you're going to multiply all 3 of these numbers. So it doesn't even matter what order you are in. So I'm going to even do back here, 6 times 6 is 36. So that is 36, and then say cubic what? Well, we're in cubic feet. This one, you would again do length times width times height. So this is a 5 by 4 by 3. So 5 times 4 is 20 times 3. Well, 20 times 3, 20, 40, and 60. So 60 cubic, and then we're talking about inches. All right, so I want you guys to try these two on your own using, so finding the volume of both of these and then comparing them using less than, greater than, or equal to. So please pause this and see and try these on your own. All right, so on this one, if you multiplied, it would have been, I just combined these and said 4, then times 8, that would have been 32. Here I combined these, which is 8 times 4, which is 32 as well. So this was equal. Here, I combined 3 times 4, which is 12, then times it by 9, which is 108 cubic feet. Then here, I did 5 times 2 was easier for me. So it was 10 times 8, which is 80 cubic feet. So therefore that would have been your greater than sign. Okay, so then on your next page, we are going to skip this next one. So number 7 is out. We are going to do this one though. It says Pila built a rectangular prism with cubes. The base of her prism is 12 centimeters cubes. If the prism was built with 108 centimeter cubes, what was the height of it? All right, so not only is the volume length times width times height, but you could also see it as the area of the base times height. So you will see it area of the base, then times height. Now, the area of the base in this case is, they already told you, is a rectangular prism. So the bottom is a rectangle. So in order to find the area of a rectangle by itself is length times width. So it's already basically combined it for you and said big B, the area of the base, the bottom shape. Remember, the base means bottom shape. So it already found your big B for you. This is the other one that you could have used, big B times H, which you'll be doing up at the high school, at the middle school. Next year, you're going to be using this kind of a formula as well, but it's not just going to be of rectangular prisms. It's going to be other things like cylinders and that kind of stuff. So big B just means the area of the bottom shape. So in this case, on rectangular prisms, they're all just rectangles. So therefore, it already told us what that base shape was. It was 12. And so they said, what is the height? So we don't know the height, but we do know the volume, which is 108. So 108 is 12 times what will give you 108 to make this true? Well, you had to just do it by 9. So therefore, the height would have been 9. So you could have also have said, oh, I need to divide this as well. Some people could say, oh, I should have divided. Can't do that. You can't do that, but it can go into this 9 times. So you're still going to get the same answer, even if you divided those numbers. All right, next thing, it says a packing company makes boxes with edges each measuring 3 feet. What is the volume of the boxes? And if 10 boxes were put into a larger rectangular shipping container and completely filled with no lapse and overlaps or gaps, what is the volume of that shipping container? So in this case, just one box would have been a 3 feet, and it said a cube. So with a cube, remember it is length times width times height, but on a cube, they're all the same. So if one side is 3, then they're all 3. So what is 3 times 3 is 9. 9 times 3 is 27. So this would be 27 feet cubed for just one box. But then they said, what if they packed it with 10 boxes? So if this is per box, then you would have just times it by 10. And that would be 270 feet cubed in the shipping container. All right, now I want you to try number 10 on your own. So please pause this and try it on your own. All right, so if you paused it on your own, you should have came out to be 60. It did not matter which way you did it. I thought it was easier to multiply 4 times 5 first, so that's why I switched it around. So then I still got 60. All right, now this is your second part of your homework. This is 11, 5, and 11, 6 combination. So therefore, this is the ones I want you to do on this page. I want you to do number 2, 3, 4, 5, and 7. You will not do 6, so you can cross out 6. So on that page, you are doing 2, 3, 4, 5, and 7. Then on the back, I want you to do 2, 3, 4, and 6. And then real cute, sorry, I just saw a cute. Real quick, what is the least number of acute angles that a triangle can have? Now remember, when it has an obtuse triangle, remember the other two have to be acute. If it is a right triangle, one of them is 90, but then there's also 2 that have to be acute. So therefore, the least number is they would have to have at least 2 acute angles in each triangle. There's no way it could be more than less than 1 acute triangle. Sorry, acute angle in a triangle. Okay, so on this one, it says Alina packed 48 cubes into this box. Each cube has edges that are 1 centimeter. How many layers of cubes did Alina make? All right, so she packed all of this, and it comes out to be 48 total in this box. 48 cubes. So this is actually the volume. So remember, with volume, you need to do length times width times height. Well, here, the bottom shape is also known as big B times H. So the bottom shape is a rectangle. So we could just fill in those numbers here. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 by, over here it's 2. So what is 8 times 2? 8 times 2 is 16. So this is 16 when you multiply those together. And now you're going to have to times it by something to see how much it would be to come to be 48. So this is where you had to actually, you could have divided to figure out how many 16s will go into 48. So can 16 go into 4? No. Can it go into 48? Yes. So then we have to guess. I'm going to try 2. That comes out to be 12, carrier 1. And that would have been 2 plus 1 is 3. So maybe I can get in another one. So I'm going to try 3. 3 times 6 is 18, carrier 1. 3 times 1 is 3, plus 1 is 4. So therefore your answer is 3 layers. And that came out to be exactly what we wanted. So therefore, how many layers of cubes did she make to make this 48 cubes in this box? It was 3 layers. Okay, and you have the rest of this for homework. Please remember that it is 11:6. This is the front. You're supposed to do 2, 3, 4, 5, and 7 on 11:6. On the back of 11:6, you have to do 2, 3, 4, and 6. Then it also, you had to do 11:5 because 11:5 and 11:6 went together. On 11:5, you had to do 2, 3, 4, 5, 6, 7, and 8. And then on the back, you were just supposed to do 1, 4, and 5. And that is all you're supposed to do for this lesson. All right, bye guys.